these would be the correct graph if A is either less than or greater than 0, and then give you something about the discriminant. So let's talk about these a little bit. So if we are looking at these graphs, if we have a quadratic, if A is greater than 0, what do you know about your parabola? If it opens up. Okay, we've talked about how that has a minimum value, it has a lowest point, it's opening up. If our A is less than 0, what does that tell us? It opens down. Then let's compare that to what we know about the discriminant. Discriminant, b squared minus 4ac. Oh, did not read myself in the front here. If that is greater than 0, we talked about the discriminant yesterday. If your discriminant is positive, what does that mean? Right, 2 real solutions. And I said the solutions, what do those look like on a graph? Yes, those are your x-intercepts. So if it's a positive, it has 2 x-intercepts. So what we know here about this graph is it would hit the x-axis twice, and we know it's opening up. So we would get a graph something like this. If it has a positive discriminant, that means 2 x-intercepts, and a negative a, then it's going to open down, and it would look like that. If the discriminant is 0, what does that mean? Right. You get 1 repeated solution. It only hits the x-axis once. So if a is greater than 0, it's opening up. If a is less than 0, it's opening down. If the discriminant is negative, what does that mean? Imaginary. When you're graphing, can we graph the imaginary numbers? No. So that means no x-intercept. So if opening up but never hitting the x-axis would look something like this. Opening down and never hitting the x-axis would look something like that. So if we know if the coefficient is positive or negative and the discriminant, we have a lot of information about our graph already. So that's the thought process that went into that last question. Hopefully you thought through it and didn't just hope for a lucky guess. I figured. Next piece that I want to talk about. Final thing in this section, we need to look at quadratic inequalities. Okay, so what do I mean when I say an inequality? Has a greater than or a less than in it. So our answer is not just going to be a single number. It will be an interval. Okay, and it might be one interval or it might be a couple intervals with a union in the middle. So let's say I asked you to solve x squared minus x minus 12 is less than 0. We're going to start out solving it just like it were a quadratic equation. So how would you solve it if it were equal to 0? What's that factor into?
-4 and 5.
Okay. So then, if we're looking for where it equals 0, that would be when x is 4 and x is -3, right? We're going to finish by kind of thinking about the graph. I don't even need a full xy axis here. I'm really just looking at my x-axis. We know it hits the x-axis -3 and +4. Okay, does this parabola open up or down? Up. So it would look like this, correct? We want to know, when is that less than 0? Where is less than 0 on my graph? Yeah, it's below the axis, this little piece. How do I know if I use parentheses or brackets? Right, there's no equal to, so be a parenthesis, starting at -3, ending at +4. Alright, you guys try this one. It has an equal to. So what does that mean when you write your interval? Brackets. So it factored into x -5, x plus 3, so it hit the x-axis at -3, +5, positive x squared, so opened up, less than was between them, the brackets because of the equal to. Right, and then I think we got it. Let's take a look at another one. What do we have to do here?
Open section.
Mm-hmm. So then that factors into x plus 8, x minus 3. Have to divide by 2. So x plus 4, 2x minus 3. We set those to 0. We get a -4 and a +3/2. So those are the points on the x-axis. And then, how did this parabola open? Up. It was a positive 2x squared, so that means it opens up. We want greater than 0. So where is the greater than? Because of the equal to, we have a bracket on the -4 and the 3/2. Infinities, of course, still get our parentheses. Okay. You guys try D. If we all get it, I won't even work it out. We got it. You got negative infinity to -1/3, union 4 to infinity. Walking around, everybody got that with the exception of a couple negatives, and I think we got those fixed. Let's look at this one. Alright. What do we need to do here? Yeah, slip and slide. But what, if you're going to do slip and slide, what do we need to be true? X has to be positive. The x squared has to be positive before we do our slip and slide. So to fix that, we could take everything times -1. If you multiply by a negative, what happens to the inequality? So then we can do our slip and slide. Okay, is there anything that multiplies 15 that's -1? No. Alright, that wasn't very helpful. What else can we do? Okay, we could find the solutions for using the quadratic formula. So opposite of b, so minus the square root, b squared minus 4 times a times c all over 2a. Also, it doesn't matter if you use the original or the one after we multiply by the negative. So I have 1 minus 60. So we get a -59 over 6. What does that mean? Yeah. When you go to draw a graph, where does I? Can we graph it? It does not hit the x-intercept. Okay, let's think about the original graph here. So we know it doesn't hit the or the x-axis, and if it was a negative, how is it opening? Down. So we have an upside down parabola that never hit the x-axis. Then my question is, when is that greater than 0? Never. This one is a no solution. Alright, I'm going to do 2 more. How would we begin on this one? Same side. It doesn't necessarily matter which. So what do you want to do? Okay, keep the x squared positive. I like that. Okay, or if you prefer to write it x squared minus 2x minus 4 greater than or equal to 0. Alright, anything that multiplies to -4 and adds to -2? No. So, okay. Opposite of b, so minus the square root, b squared minus 4 times a times c over 2a. So this is a 4. This is where I saw a lot of mistakes last night. minus 4 times 1 times negative 4. So it's minus negative 16, so it becomes a positive. Okay, 20 can break into 4 and 5. That's 2 plus or minus 2 radical 5 over 2. Or 1 plus or minus radical 5. So that means we hit the x-axis at 1 minus radical 5 and 1 plus radical 5. How does my parabola open, up or down? Up. We wanted greater than 0, so we need these two ends. So negative infinity to 1 minus radical 5 equal to means bracket and 1 plus radical 5 to infinity. So you might have some uglier answers in your interval. You can have the radicals, things like that. Alright. I'm going to give you guys one. I want to see if you can figure it out, and then we'll talk about it. Any questions on this example? So, this one factors nicely. Multiply to 1 and add to negative 2. Set those to 0 and we only get x to equal 1. How do we write that solution, by the way, if you get the same answer more than once? Remember that. Okay, this parabola opens up. I wanted to know when it was greater than 0. That's above the axis, but not equal to. So that means we don't include the 0. So what would I write? Good. What if I had asked when this was less than or equal to 0? It's never less than 0. Is it ever equal to 0? 1 would have been the only solution to that. If I had just said less than 0, then it would have been no solution. If I had said greater than or equal to 0, negative infinity to positive infinity, because it would be a greater than or equal everywhere. Okay, so lots of different questions I could ask. Last thing, using this graph, can you tell me how many solutions are there to the equation f of x equals 3? So, we didn't draw a real precise graph, but we said it hit the x-axis here, and it looked like this, right? F of x is the same as what variable? So I'm asking you how many times on this graph does y equal 3? 2 times. What if I'd said f of x equals 0? 1 time. If I had said f of x equals negative 1, it would never happen. Okay, so f of x is just like saying if you put a horizontal line at that y value, how many times does it hit our graph? Any questions? Okay, then I am done. So there is a Math Excel assignment open, and if you had a couple questions to wrap up from last night, you have time to get that